Hello and welcome to the workshop, and as you may have noticed, this is a Thunder Laser video. So in today's video we're going to find out whether this Nova 35 100 watt laser really is the AMG of CO2 lasers and take it all the way up to 1,000 millimeters per second engraving speed. Okay, so I've got Lightburn up and now I'm going to import a file from my desktop. That's the file there. That's the normal one that I use. It's a grayscale test card. And we'll make it a bit smaller because it's quite large at the moment. I think we'll go down to 75, 80, make it 80. And press enter. That's okay. It really doesn't matter where it is on the table on here. I've got the orientation set up in this top corner here, and I can place it anywhere I wish on the cutting table. So we're going to double click this. I have done a couple of tests already. As you can see, it's set at 1,000 millimeters per second there. So we're going to start off first of all at 500 millimeters per second. The maximum power is set in this case because it's a grayscale image. I set at 99% and 2%. I know that the laser will drop out below 2%. Look, it's just habit. I could run this at 100% because the Thunder Laser is designed that you can actually run it at 100%, but it's just habit that I just put a maximum of 99%. The air assist is turned off, and with the Thunder Laser, because it has dual air blow-in, this means that the laser will select a low pressure evacuation or blow system, which is exactly what we want. Scan line, look, 0.1 millimeters is fine. I'm using the standard 2-inch lens, which equates to 254 DPI, dots per inch. Incidentally, what Lightburn will do is separate the percentage of power output into 255 different levels. In other words, between white and black, there's 255 different grades. So that's what Lightburn will actually do. Okay, so I'm okay with that. Nothing else needs to be changed on grayscale. That's okay. So it's going to treat this like a black and white photograph, in other words. So all I'm going to do now is fire the laser up and send this file to the laser. Okay, so let's fire this laser up. There's two switches down the side here. The top one switches the main control board on and the systems within the laser, and the second switch will switch the laser system itself on, and there will be an alarm. Okay, so it's now armed, and in a minute or two the refrigeration system, cooling system will actually fire up and do a cycle and shut down again. while it's doing that, I'm just going to take this front cover off. Just makes it easier for me to film through. That's the refrigeration unit. So this particular refrigeration unit that I've got with this system, it just shut down. It'll keep the tube at a constant, I suppose, between 15 and 20 degrees C, unless it gets to about 40 degrees in here. Then it'll hold it about 20 to 22 degrees, which is perfect. Okay, I'm just going to drive the table down a bit. Okay, I'll just bring you in a little bit closer so you can see what I'm doing. Okay, back here you'll notice a little black block here, and there's one on the other side over there. Now that is the automatic Z setting or height setting system. So providing your material is between those sensors, it needs to be between those sensors to pick it up. And of course, with the table height or Z height, you can put the material anywhere on here after you have set the Z. So that's what we're going to do now. So I'm going to press menu. Autofocus is the first thing that comes up on here. Press enter and it will automatically focus, which is perfect. I'll bring this right down the front, roughly square. This is just a bit of 3mm ply. It's fairly good ply, you know, it's nice, and this is actually very nice for doing photographs on. It's very good. Okay, the next thing I'm going to do now is just bring the nozzle over and make a datum there. That looks okay. So I'm going to press origin and I'm going to press frame. So that's where it's going to put it. Okay, so I'm going to set the camera up now to look into here so you can see this. I'll start off in real time, and then I'm going to speed the footage up because, you know, otherwise you're going to get bored sitting there for a couple of minutes just watching this going back and forth. Okay, all is ready. I'm just going to turn my extraction system on. That makes more noise than anything actually. So here we go. So that's the extraction system, and we'll press go. I'll just give this a quick brush. And a bit of a wipe with a cloth. Obviously this would come out an awful lot better if I put it under water and gave it a scrub, but it just gives you a good idea of, well, it's a perfect result at 500 millimeters per second. Okay, let's get set up for 1000. Okay, we have our test CAD selected, so we double click on this and now set it at 1000 millimeters per second, and we'll OK that and send it to our machine. Okay, so let's choose our new datum point, which I think that will be fine there. Press the origin. Let me zoom into that area. Okay, so here we go with 1000 millimeters per second. Extraction on, and away we go. Okay, let's give this a bit of a brush up and a bit of a wipe off. And as you would expect, you know, it hasn't burnt as deep, but everything is there. You know, it's probably about half a millimeter deep there, maybe a little bit more here. Yeah, the writing's okay. The finer writing, maybe not quite so much, but the larger writing is fine. Crisp edge, but smaller writing, not as good. So obviously, you know, sort of 500-600 millimeters per second for perfect engraving with a laser. But you know, there are certain jobs you can do at 1000 millimeters per second, and there's the proof that it will actually engrave at 1000 millimeters per second. What makes this possible, I hear you say? Well, it's fairly simple engineering, actually. Quite a bit more expensive engineering, but engineering just the same. This is a pretty standard stepper motor, and if you notice, it's the same size as the one over on the back there running the Y-axis, except on the back of it there's another little unit. Now inside that unit there's a pickup, okay, that tells the driver that's sending messages to that stepper motor is actually a servo motor. It sends messages to it telling it how many degrees to turn over what period of time, and that pickup on the back sends messages back to the driver and the controller saying, yeah, done that, what's the next thing you want me to do? Normal stepper motors, such as this one, just receives messages or pulses. It has no way of communicating back. That's what makes this whole system different. There is two-way communication. So you can run at very fast speeds. But it doesn't quite end there. The laser operating system, in other words, the laser power supply, sending power to, or pulses of power to the laser tube, and the laser tube itself is all designed to operate at these upper speeds. If you buy a laser off eBay or Alibaba or anywhere else, you're not going to get that. You're going to be very lucky to operate at 300 millimeters per second. That's the difference. This is an industrial machine. And you know, there's an old saying, and I keep on saying this on my videos: you get what you pay for. And this is the type of thing you're paying for. Servo drive systems, high output laser systems, so you can run it at industrial speeds. So there you are, a conclusive demonstration of a thunder laser operating at 1,000 millimeters per second. It's not the Ferrari or the Maserati of the laser world, but it could be regarded as the AMG. It's got a lot of grunt, pretty decent high-tech systems, and it does the job at a reasonable price. If you're interested in a thunder laser, it is far better for you to contact your local outlet for thunder lasers. They have outlets all over the world, in every major country, America and Europe and Australia, and you name it, they've got it. And don't forget the old saying, you get what you pay for. So on that note, thank you for joining me. Please press like and subscribe. And if you really like what I'm doing, you may consider becoming a patron to the channel, because it is the patrons behind the channel that keeps it running and allows me to make videos like this. So thank you for joining me for this video, and it's bye for now.